Hello everyone. Today I would like to give you a lesson on the topic circle and disk. Before starting to watch this video, don't forget to subscribe to my channel and like it. I will be very grateful to you for that. Imagine a drop of water falling on the calm surface of a lake. Smooth, flowing waves spread out from it, and each of them has the perfect shape of a circle. Or look at the sun, a clock face, a bicycle wheel. These images accompany us every day, even when we don't think about it. Today in the lesson, we will embark on a journey to one of the most harmonious figures in geometry, a circle and a disk. These are not just lines and formulas from a textbook. A circle is a symbol of perfection and balance, but a disk is a space in which many interesting patterns are hidden. Understanding these figures will help us better explain the world around us, from the movement of planets to the operation of modern mechanisms. So let's tune in to research, discovery, and logical thinking, and try to see something truly amazing in an ordinary circle. So first, let's find out, what does the circle means? A circle is a geometric figure consisting of all points on a plane that are in the same distance from the center. Here are these interesting circles in front of you. Here is the formula for finding the circumference of a circle. L equals 2 pi r, where L is the circumference of the circle. Here I have highlighted it in green. Pi is a number that is equal to the ratio of a circle's circumference to its diameter, and pi is a constant. R is the radius. I have highlighted it in red. And also let's find out what the equation of a circle is. The equation of a circle in Cartesian coordinates is x minus x sub 0 squared plus y minus y sub 0 squared equals r squared, where x, y, coordinates of any point on the circle, x sub 0, y sub 0, coordinates of the center of the circle, r, radius of the circle, i.e. the distance from the center to any point on the circle. Next, a disk is a part of the plane bounding by a circle, including all the interior points and the circle itself. Here are these interesting disks in front of you. A circle and a disk can be distinguished by their nature. A circle is only a boundary, while a circle includes everything that is inside that boundary. Let's learn the formula for calculating the area of a disk. S equals pi r squared, where S is the area of the entire disk and r is the radius. There is also a term in mathematics called a segment. A segment is a part of a flat disk that is bounded by an arc of a circle and its chord. Here is the chord AB. I have highlighted it in white. So this part of the flat disk that I have highlighted in yellow is a segment. There is also a term in mathematics called a sector. This is a part of a disk bounded by two radii and an arc connecting the ends of these radii. Imagine that you are dividing a pizza comparatively, and each slice of it that any person gets will be called a sector. You can also find its area using the formula S equals pi r squared alpha divided by 360 degrees, where alpha is the angle between these two radii, which I have highlighted in yellow. So please remember what radius, diameter, and so on are. So radius is a line segment that connects the center of a circle or sphere to any point on that circle or sphere. I have highlighted it in yellow. Diameter of a circle is a line segment that passes through the center of a circle and connects two of its points. I have highlighted it in purple. By the way, remember that the diameter of a circle is equal to 2 radii, because the diameter is made up of 2 radii. Chord is a line segment that connects 2 points on a circle. I have highlighted it in blue. A secant is a line that passes through any 2 points on a circle. I have highlighted it in green. And finally, what is a tangent? It's a line that is perpendicular to the radius of the circle. I have highlighted it in red. Problem root 1. Determine the unknown quantities using the given data in the first figure. We see that the circle is inscribed in the triangle. We are given a diameter of 18. Find the radius. Well, as I just wrote to you that the radius is equal to half the diameter. So we write this down and get that the radius is equal to 18 divided by 2 equals 9. The answer is 9. Let's look at the second picture. We see that the circle is circumscribed around the arbitrary triangle. So we are given that the sine of alpha is 1/3. Well, here we know that we need to remember the theorem of sines. It says that the ratio of a side to its opposite angle is equal to 2 radii of the circle circumscribed around this triangle. We substitute sine of alpha for 1/3, and we get that 45 equals 2 radii. From here, we find the unknown factor. We divide the product by the unknown factor, and we get that the radius is 22.5. This is our answer. Figure number 3. We see that the circle is inscribed in the equilateral triangle, and we know that in an equilateral triangle, the height will be both a median and a bisector. So by the property of the medians of a triangle, they will be divided in the ratio 2:1 when they intersect, starting from the vertex of the triangle. Therefore, r equals 1/3 times 18. This will be equal to 6. The answer is 6. Figure number 4. We see that the circle is circumscribed around the right triangle, and we see that here the diameter is our hypotenuse. So we must remember the Pythagorean theorem, which says that the sum of the squares of the legs is equal to the square of the hypotenuse. So we substitute the corresponding values instead of the legs, and instead of the hypotenuse we will have the diameter. From here we find the diameter, and also remember that the radius is half the diameter. Instead of d we substitute the number 17, and we have that r equals 17 divided by 2 equals 8.5. This is our answer. Problem root 2. Determine the unknown quantities using the given data. Well, we see that we have a circle inscribed in the square. I mark its side in green. Remember that the perimeter of a square is equal to the sum of its sides. If we have the same sides in a square, so we simply write that the perimeter is 4a, hence I will substitute 36 instead of p, which we have by condition. Hence 36 equals 4a. I will find what the side of the square is equal to. A is equal to 9, and remember that the diameter of the circle in this case will be equal to the side of the square. So if we know the diameter of the circle, then we also know the radius, which will be equal to 9 divided by 2 equals 4.5. Figure number 2. We see that here we have a circle described around the square. We are asked to find the radius of the circle that is described around a square. So to solve this problem, we must remember the Pythagorean theorem. So instead of the legs, we must substitute the corresponding letters. Hence d squared is equal to 2a squared. By the condition, the area is equal to 36. So the area is equal to the product of the two sides of the square, a times a. So a squared is equal to 36. Now, instead of a squared, we will substitute 36, and we will have that d squared is equal to 2 times 36. Hence, the diameter is equal to 6 root 2. So if we found the diameter, then we can already find the radius accordingly. It will be equal to 3 root 2. This will be our answer. So if you understood everything today, I would give you Graph Diamond's hallucination as a gift. If you are worried or excited because you didn't understand something, no problem. Watch this video again slowly. Never give up. And I wish you to understand it as soon as possible. Bye!